quick summary, an atom is the building block of all matter. It contains smaller parts. Inside the nucleus, we have protons and neutrons, both having about the same mass, but the proton has a positive 1 charge. The neutron has no mass, and the symbols are shown here. Electrons are found outside the nucleus. They have an opposite charge to that of a proton, and their mass is so small that we generally consider it to be 0. The word is negligible, meaning not exactly 0, but so small that it can usually be considered to be 0. In a neutral atom, the number of protons equal the number of electrons. And the number of protons in the nucleus of an atom is the identifying feature of an element. For example, we see carbon has 6 protons in the nucleus, and in fact, any atom that contains 6 protons and only 6 protons in the nucleus will be an atom of carbon. Every element has at least one isotope. Isotopes are atoms that have the same number of protons but have different numbers of neutrons. Neutrons have 0 charge, but they have about the same mass as a proton. The notation of an isotope is given here. We have preceding superscripts, which correspond to the mass number, and a preceding subscript, which corresponds to the atomic number. Atoms can lose or gain electrons, resulting in ions. Ions have a net charge. We can find the net charge or determine the net charge by the number of protons minus the number of electrons. Let's work through a few exercises. We want to determine the number of protons, electrons, and neutrons in each of these entities. Now, if you notice here, each of these is missing the preceding subscript. The preceding subscript is that of the atomic number. We can obtain the atomic number directly from the periodic table. So for each of these, we're going to go to the periodic table, find where this element is within the periodic table, find its atomic number, and write it in. These preceding subscripts correspond to the atomic number associated with each of these elements. Now that we know the atomic number, we can immediately write in the number of protons that are associated with each of these. To get the number of electrons, we look at the atomic number and the overall charge. When we look at manganese, we see a +2 charge indicates that we have 2 less electrons than we have of protons. For the oxide ion, we see we have a -2 charge. That means there's 2 more electrons than there are of protons. In the aluminum 3+ ion, we have 3 fewer electrons than protons, so 10 electrons in the aluminum 3+. Cesium, +1, that means we have 1 less electron than we have protons. Let's determine the number of neutrons. If we look at our symbol, we see 55 is the number of protons plus neutrons, 25 is the number of protons, so if we simply subtract, we're going to get the number of neutrons. So we have 30 neutrons for this manganese ion. The number of neutrons in the rest of these ions is then quickly determined. There is some small amount of memorization that's required in chemistry. One is elemental symbols. Now we've learned that an element is a pure substance that cannot be broken down into simpler materials by ordinary chemical means. We've seen the periodic table of the elements and the chemical symbols. The symbols are 1 or 2 letter designations for each element. The first letter is always capitalized. The second letter, if it's there, is never capitalized. The reason for this is it allows us to distinguish between CO, which is the element cobalt, and CO, which is the carbon monoxide. So you have to be careful to distinguish whether these letters are uppercase or lowercase. While there are well over 100 elements, these are the elements that you should know, memorize. You should know the name of the element, along with its elemental symbol. A compound is a combination of two or more different types of atoms. Here we see two different compounds. We have a compound of carbon dioxide. It contains one atom of carbon, two atoms of oxygen. Carbon monoxide has one atom of carbon, one atom of oxygen. Both of these are compounds. They have different types of atoms that are combined. The formula of a compound indicates the number and type of atoms in the basic unit. We've already talked about carbon dioxide, one atom of carbon, two atoms of oxygen. Note this subscript. The following subscript indicates how many we have of everything that's immediately in front of us. So this subscript 2 tells us we have two oxygens. For carbon, we don't see a subscript, and when that's the case, it's understood that that subscript corresponds to 1, so we have one atom of carbon. For carbon monoxide, we have simply one atom of each. Before we go on, I want to talk about the basic unit of a compound. We need to distinguish between molecular compounds and ionic compounds. For a molecular compound, the basic unit is going to be a molecule. For an ionic compound, this is called a formula unit. Another bit of necessary memorization is to memorize the names, formulas, and charge of the following polyatomic ions. There are many, many polyatomic ions. These are the most common, and those that are highlighted in bold are the most common of the most common polyatomic ions. These polyatomic ions are atoms, groups of atoms that are held together by covalent bonds but possess a net charge, and they tend to stay together in chemical reactions. A quick and easy exercise testing your understanding of formulas. How many atoms of each element are present in one unit of the compound below? So for potassium oxalate, we see that there are 2 potassiums, 2 carbons, and 4 oxygens. This is sulfurous acid, and we can see that there are 2 hydrogens, 1 sulfur, and 3 oxygens. This subscript 2 tells us we have 2 of everything that's inside these parentheses. So we have 2 nitrate ions in addition to 1 copper. So in terms of overall numbers of each atom, we have 1 copper, 2 nitrates, that means we have 2 nitrogen atoms, and we have 2 times 3, or 6 oxygen atoms.